Hey everyone, today we are solving the add and search word problem on LeetCode. We're going to design a data structure and it supports the following operations. We're going to add a word and search for a word. And the search word can search either for the actual word or a regular expression containing only the lowercase letters A through Z, or a dot, which can represent any one letter. So here's what the example looks like. Add to the dictionary. Search for bad is false. Search for bad, false and true. You can see that there. Search for .ad returns true. Okay, because that can match with bad, dad, or mad, because that dot can represent any letter. And then b dot dot also returns true because that matches with bad right here. B dot representing any letter, in this case A, dot representing any letter, in this case D. So when you think about this problem, obviously if we didn't have to worry about the regular expression matching, we would just take a hash set, put the words into a hash set, and then check if we have them. That's obviously super simple, and we have no need for an extra special data structure that does that. So in order to support the searching using regular expressions, we're going to use a try data structure. Okay, if you don't know how tries work, they're super important and really helpful for problems like this. Definitely go check out and really get comfortable with how tries work. But I'll run through the try code that I wrote here just to give you an idea of how the try works, and then we'll talk about how we solve the problem. So here's the node. This is a node in the try. You can think of the try as a tree, okay, and here's the node. The node has neighbors, which are represented as a map. It takes a character to a node, meaning that node has a character following it in some word of that character, and then a Boolean flag that just says is word. And then these are just sort of some getters and setters for those. We don't have to go through those. I'll pause it there so you can just take a look at the complete class of node. Now a try, it has a root which is a node, okay? And the try is basically, you can think of it as a n-ary tree. It starts at the root, and then it's an n-ary tree which holds all the words in your dictionary, okay? So when we need to add a word to the try, what we'll do is we'll start at the root, and then for each character in the word, we will just loop through there. And if the node does not have it, we just add it, and then once we get to the end, we set it as a word. Now, we will talk about this contains for our regular expression as we just add the word that we just saw and add the try. And search and return try contains that word, and we'll walk through that code. This is what is the word, okay? And this contains, what we're going to do is we're going to do a depth first search walk through the try, okay, starting at the root. So that's basically what we're going to do. So here's sort of conceptually what we'll do. We'll start at the root and do a depth first search. And what we'll do is, if we encounter a character in the word that's not a dot, then we'll just make sure that the current contains that as a neighbor, and we'll return the first search for that neighbor. If it is not, we're going to do is make sure that it's going to contain the character. Okay? And in order to get any character, we'll try all the neighbors are in our node. We'll try all of them, and if we find that it's a word for any of those neighbors, then we return true, because it could be any character. Okay? So here we'll do depth first search from the root. It takes in the character array and the index for the character we're currently pointed at. So here's our base case. If the index is equal to the length of the array, meaning we're at the end of the word, then what we have to check is the root is not null, and the root is a word, meaning where we are at is a word. Okay, that means we've matched a word, and we can return true. If not, it will return false. If the root is null, it returns false. It means that we've found something. We found a character that did not match in our tree. And right here, if we're looking at something that's not a dot, Okay, then what we need to do, we need to make sure the root contains that. Okay, it contains that character. And then we just run that first search from that neighbor using index +1 to point to its character. Okay, so now if it is a dot, what we have to do is we loop through each neighbor of the root. Okay, because it could be any character. We have to check each neighbor that the root has, and we run that first search for that neighbor and index +1 as well, and we return true if we find it for any of those. And then at the bottom here, if we haven't found anything, we return false. Alright, so it works. A little confusing, but it just comes down to using a try. Again, if you don't know how tries work, go check it out. Any of these problems where you're doing these sort of string matchings, tries will help out a lot. Here's the node class once again. Pause the video, just take a look at the code for the node class. And then the try. Here's the try class. We can't get it all in one view, but it's close. There's the remainder of the try class. And then down here is just the code that LeetCode initially gives you. So we went through that kind of fast, but again, the whole idea is we do a depth first search from the root of the try, and then basically if we encounter a dot, we try each of its neighbors, and if it's not a dot, then we just make sure that it contains that character, and we continue to search for the next character.